Hello, good peoples. This video is a continuation of chapter 3 for statistical elementary statistics. So if we left off, we talked about, or before we left, we were talking about independent events. So two events A and B are independent if the knowledge that one occurrence does not affect the other. That means if we roll a fair die, those two events are independent because if I roll a fair die once and I possibly can get a 1, and the second time I can possibly get a 2, then that has no bearing on the die roll that we have done. Okay, so if we have the probability A given that B has occurred, then the answer would just be the probability of A. If we have the probability of B given probability A, then we have the equals to the probability of B. If we have the probability of A and B, then that means we multiply the two together. Okay, so again, the example that I'm giving you is again talking about the two fair die are independent events. One roll does not have any dependence on the other. They are two independent events. All right, and when people are independent, we say that and if the two events are not independent, then that means that they are dependent, meaning somebody depends on you. If we move now to sampling with replacement or without replacement. So we talked a little bit about this in class the other day. With replacement means you plug whatever your probability is, you plug it back into your sample. Or if we're saying without replacement, then that means we choose something, but we take that second, we do not put the probability that the event goes back into it. So if I talk about really quickly what I mean by that with replacement is if we have a 52 deck of cards and I pull out a queen of spades, if we put the card back and pick up a second card and it's a 10 of clubs, then you put this card back. But the probability of queen of spades is 1 out of 52. And then if we plug it back in and now we get a 10 of clubs, well, then our probability of the 10 of clubs is still going to be 1 out of 52 because we still replaced the card. However, without replacement means that we are going to not put the club or the card back in. So without replacement means let's say the same thing, the queen of spades. Well, if we pull a queen of the spades, that would be 1 out of 52. But if we now want to do, I'm going to just say a QS, the probability of QS is 1 out of 52. But if we're doing without replacement and we want to do the 10 of club, right, the 10 of C, right, then that means it'll be 1 out of 51. Okay, that means we reduced it because we did not place that queen of spades possibly back in there. All right, mutually exclusive events. A and B are mutually exclusive if they cannot occur at the same time. This means that that means that A and B do not share any outcomes, and probability of A and probability of B, okay, are equal to 0. So if we look at our sample space 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we let A equal to 1, 2, 3, 4, 5, and B equal to 4, 5, 6, 7, 8, and C equal to 7, 9, right? If we were to hypothetically say, find the probability of A and B, well, the probability of A and B is, remember, and means the intersection, right? So the probability of A and B will be 4, 5, right? So if we look at these, the probability would give us 2 out of 10 because we have 10 numbers in our sample. So this is not a mutually exclusive if we're looking at probability of A and B because it does not equal to 0. However, if we did the probability of A and C, right, Do A and C have anything in common? They don't have anything in common. So the probability of A and C is 0. So this is mutually, if I can spell, exclusive. Okay? All right. That's just another rule. We don't have to do the fair coin. I'm trying to keep the video short as possible. So the multiplication rule is if two events, A and B, are defined in the sample space, and we want to find the probability of B, or A and B, or B times the probability of A given B, right? If the A and B are independent, we would use this formula here, okay? Or if we had to, if they're not independent, then we would use these rules here. For the addition rule is about the same thing. If A and B are defined in the sample space and probability of A or B, so that means we would add the probability of A plus the probability of B and subtract that by the probability of A and B. And again, if A and B are mutually exclusive and they equal to 0, then we would use this formula right here. Okay? So, in my first example, or example number 8 from our notes, it says Juan is trying to choose where to go on vacation. His choices are A equals to New Zealand, B equals to Alaska. Juan can only afford one vacation, like most people. The probability that he chooses A is P, probability of A equals to 0.6. And the probability that he chooses B is, probability B is 0.35. So the probability that he does not choose to go anywhere on this vacation must be, excuse me. So we're looking at the probability of A and the probability of B, right? So the probability of A plus the probability of B minus the probability of A and B. I think I left something off. All right. So this would be 0.6 plus 0.35 minus the probability he doesn't go anywhere is 0. So when we add that all up, I think I really did leave. Oh no, I didn't. Is had to get a calculator, 0.95, right? So that's the probability that he will go somewhere, right? And the probability that he will not go somewhere. Remember, probability is 1, can't be greater than 1. So 1 minus 0.95 equals to 0.05. Okay? All right. Example number 9. We'll do 2 more. So, a student goes to the library. Let events probability at B equal to the students checks out a book. And probability D is that the students check out DVDs. Suppose the probability of B is 0.4 and the probability of D is 0.3. So, and the probability of D given B is 0.5. So, if we want to find the probability of A and D, I'm sorry, B and D, right? Well, that means that we're going to find a probability of B intersection D. So that is the probability of B times the probability of D given B. So this would be 0.40 times 0.5, which equals to 0.20. Now, if we wanted to find the probability of B or D, well, B or D is the probability of B union D. So that would be the probability of B plus the probability of D minus the probability of B intersection D. Oopsies. I had bad handwriting on this video. Terrible. All right. So if we look at it, the probability of B is 0.40. Probability of D is 0.30 minus probability of A or and D, right? A and D is 0.20, right? So when we add that all up, we end up with 0.50. Now, if you're asking where did they get the 0.20 from, well, this is from right here, the probability of B and D. Okay? All right. So example